Bismillah, Assalamualaikum warahmatullahi wabarakatuh. This is Statics Tutorial Chapter 3. We will be dealing with equilibrium of a particle for two-dimensional problem. Right, so today's tutorial focus on equilibrium of a particle for 2D. Right, for 3D we will be doing it for the next tutorial inshallah. And in the past we have covered all that we need to understand from chapter 2, right? So by now you should already know how to deal with vector, how to resolve vector, how to express vector in Cartesian form, how to add vector, etc. All those are fundamentals before we go to chapter 3, where we will be dealing with equilibrium inshallah, right? So as usual, the questions are from the past exam questions, mainly from midterm questions. You will find the PDF of the question that we will be covering today in the description box below. You can download it, see the questions, and select which question that you want to go through in this tutorial inshallah. Up to you. We will make the timeline segregated into the question inshallah. Right, so without further ado, let's go into the first question for today. Okay, this is the first question for today. We have the diagram on the right, and then the question said, determine the unstretched length of dB to hold the 40 kg crate in the position shown. Take K equal to 180 Newton per meter. Right, so first thing first, you have to understand what the question gives and what the question require us to determine. So in here, if you read the question again, what we need to determine at the end is the unstretched length, meaning that the length before the spring is stretched, right? The current length you can determine from the diagram, but the unstretched length you need to calculate first S, which is the stretch, right? The elongation of the spring. That will require you to determine the force first, because from F equal to Ks, if you know F, you can know S, considering that in this question K is given, right? So how to get that F in the first place? So it requires you to solve equilibrium problem about point D, right? So that's the thing that you have to be able to think in your mind before you start to compute anything, right? Okay, so the diagram is over there. Yeah, straightforward I think. In the sense that, okay, this is an equilibrium problem. It is equilibrium of a point of a particle. The particle is point D, right? Of course, it is obviously right now because we are learning about chapter 3, which is equilibrium of a particle. But in the midterm or in the final, you already have learned something else after this, which is equilibrium of something else, not just a particle, right? So it is important that just by looking at the question, understanding the question, you know, oh, this relates to equilibrium of a particle, because it will dictate what is the steps next. If it's from the different chapter, the steps might be a bit different. Yeah, I think you understand that. Alright, so going here, so the first step is okay, if you go backwards, right? If you go to the final, what need to be determined? Stretched length, right? So that is the question, what the question want. Is it clear? Okay, so my marker, I need a new marker then. So basically what is LO, right? That is what the question wants. So we know from spring F equal to Ks, where S is basically L minus LO. Right, so having this mapped out, because currently from the diagram there, L is known, right? Meaning not known, we can measure that one, right? From 3, 4, 5, we know that one, right? What we need is this one. So we need to find S first, and that from here, K is given, so we need to find F first, right? How to get this F is from equilibrium of the particle D. So that is where we begin. And as usual for equilibrium problem, we need to start with free body diagram. This is where it is different than chapter 2. Make sure you understand this as well. Because in the final, you have to understand the question, and you have to understand whether you have to draw something or not. If the question is about resultant force, etc., projection force in chapter 2, there's no drawing needed in terms of free body diagram. You might need to draw something else in terms of getting the theta, etc., maybe. Right, but for equilibrium problem, equilibrium problem, the first step is free body diagram, right? So free body diagram, and given that free body diagram is one of your learning outcome, if you go to the course outline, one of the learning outcome is know how to draw the free body diagram. That is why free body diagram tend to have significant marks. If you draw it wrong, even if you calculate later is correct and your final answer is correct, you still lose a lot of marks for your free body diagram. So make sure you understand that and know how to draw free body diagram correctly. Alright, so free body diagram of point D, right? So we have point D here. And then we draw forces on that point. So we have one force from the box, one force in the direction, go to the spring, and another force here. That will be the free body diagram. Of course, we haven't drawn it completely yet, but this is the basic, right? So this will be the weight of the box. This is, we can label FBD, for example, or F spring, whatever you want to call it. This one we'll call it FCD. Okay, your label you use here should match the label you use in your equation or your solution, basically, right? Because some students do this mistake. They I don't know what they label here. For example, just D, and then they say, sorry, this is D, this is B, right? They do something like that, and then suddenly F, D, B. This doesn't make sense because this should be the label of the force. It's not. If you are, when I ask the question, what is this, and what is this? They say this is the force, this is point. If you are saying that this is point B, which is in the diagram there at the end there, then of course this is not free body diagram, because free body diagram by definition you already cut off from the surrounding, meaning point B, point C, the box, the spring, all of those should not be in the diagram, right? Because if it is still in the diagram, then the body is still not free from those things. Then it is not a free body diagram, right? So hopefully you understand that concept. When we say free body diagram, it should be free from all the surrounding. Meaning that's why if you draw the spring, wrong. If you draw box, wrong. If you draw point C, wrong. If you draw point B, wrong, right? So you will lose a lot of mark if you do that. Make sure you understand that. If you don't understand any of the thing that I mentioned, just ask in the comment section below. I'll be happy to explain, inshallah. Alright, so the angle here we have 345. Hopefully you know where do we get this also, right? This is not drawn in the original diagram, but we know this is 3, 4, so it should be 345, right? I think by now that ratio is we are familiar with it already, right? Here you can use 1 square root of 2, or okay, if I use 1 square root of 2, right? 1 square root of 2, or you can say also it's 45 degrees. Both will be correct, right? Because we know from the diagram it's 3 and 3, so it should be 45 degrees, or the ratio of 1 square root of 2. Both will be correct. Okay, but it should be consistent in the drawing and what we use afterwards. Okay, that's the free body diagram. If you miss the angle, some mark lost there. If you do not label properly, mark lost there as well. If you draw something that should not be there, if you draw the spring, mark will be lost as well. Alright, so from here we know there's two equations that we can use: summation of fx equal to 0 or summation of fy equal to 0, right? So let's use, of course in here in this case it will be simultaneous equation, right? So if you do summation of fx equal to 0, positive to the right, you will have f bd, and then this is x, right? So 4/5. Hopefully you understand this already from chapter 2, right? By now, starting chapter 3 onwards, all of this should be automatic already, knowing how to use this thing. And then minus fcd 1 over square root of 2 equal to 0, right? So this is equation 1. Of course, if you want to rearrange so that you can just plug in afterwards, also fine. For example, if I want to rearrange as, let's say FCD equal to, I bring it here, so FBD 4/5 then times square root of 2, right? It will be like that. This is just rearranging, right? And then if you do summation of Fy equal to 0, now do you have to write this? You have, if you do not want to lose the mark, because this is the equation of equilibrium, the starting point before you go to this one, right? And then there's a mark for stating this, there's a mark for stating this one, right? If you suddenly do not write this, or you jump this, suddenly you go here, because many of you can do this in your head, right? But you actually, because this statement is crucial to illustrate that you know how to express the equation of equilibrium, because we want to know also, okay, positive, negative, etc., right? Especially in case of mistake. Now anyway, so here, so you'll have FBD 3/5 plus FCD 1/square root of 2 minus W equal to 0. Do I have enough space here? So I'll continue here, right? Hopefully there's enough space over there. Oh, okay, so from here I can plug in FCD inside here, right? So I plug in FCD inside here. Wait a minute, we already know W, right? Yeah, sorry, W is known. Okay, so I have to read, and this is just for you as well, right? This free body diagram actually is missing something, because in the concept of a free body diagram, if you go back to the lecture, any known value should be put here. What is the known value? Any unknown should be labeled properly. So this is labeled. This one is known actually. It's 40 kilograms, so equal to 40 times 9.81, right? Or it will come 392.4 Newton, right? 392.4 Newton, right? So basically this one, if this is already here, this will be minus 39, okay, minus 392.4 Newton equal to 0, right? That is the full equation of equilibrium, right? So now we will go to the next step. This is plugged in here, so we rewrite this one. So FBD 3/5, and then plus FCD, we plug in the whole thing here, so plus the whole thing here is FBD 4/5, and then square root of 2. This is the whole FCD here, and then we have this one, so 1/square root of 2, and then minus 392.4 equal to 0, right? Right, so you can rearrange this. So this one, if you calculate what you get 7/5, right? So this portion here you get 7/5 FBD, and then this will bring over the other side, so 392.4. So FBD, if you calculate, you'll get, okay, my number is in fraction because I do not want to round off yet, because I don't want to introduce error yet. So 1962/7 Newton. Yeah, FBD. Yeah. So why do we need FBD? Because this one, right? What F equal to KS is for FBD, right? So we know this already, so we can use this. So from F equal to KS, so now If I already write this one in my answer paper, then fine. If I haven't, I have to write here F equal to KS from F equal to KS. So FBD is 1962 over 7 equal to K is given, right? In the question just now 180. 180 times S. So here S equal to, you can calculate to be 1.557 meter. Right, 1.557 meter. Do verify the all these numbers, right? Do calculate and verify in case I make some mistakes. So what is this? This is the stretch, right? Meaning the spring has been stretched with this length. Meaning, if you go back to the original spring length, right? So we have here, right? Point D and B here. This length is 5 meter, which is L is 5 meter, right? So from here, S equal to L minus L naught. So meaning from, can you see on this side? Okay. So from S equal to L minus L naught, S is 1.557, L is 5 minus L naught. So L naught you can calculate to be 3.44 m. Right, it will become 3.44 meter. So that is how you solve for this one using the equation of using the equilibrium solution, equilibrium of a particle, equation of equilibrium, and then apply the understanding from spring. This is purely about spring, F equal to Ks. Right. Hopefully you have understood. Of course, in the calculation, I already have the intention to know FBD, right? Because I know I want to know this one. So that is why when I do this simultaneous equation, because I don't care about FCD, I don't care about this one, I want this one. So that's why I use this one, so that when I plug in, I only have FBD. If you do your simultaneous equation, you find CD first, the answer should be the same, but you have one added steps basically in the calculation. Not a problem, the answer will be still the same. It's just that sometimes you do not want to waste that much time, because I have to admit I'm kind of a lazy person, so I always try to make it short if possible, right? Okay, so that's the first question. We'll move on to the second question. Okay, this is the second question for today. On the left is the diagram, and the question says, determine the magnitude of the force F2 and the distance y if X is given as 1.5 meter and F1 is equal to 1000 Newton, right? So basically in the diagram, it is given in terms of X, Y, F1 and F2. However, X is already given as 1.5 and F1 is actually already given as 1000 Newton. Right, so we'll put the diagram there. Sorry. Here the crucial point is, there are several points. One, you have to understand, okay, this is still about equilibrium of a particle, right? And the particle is point B, right? That's the first thing that you have to really be able to decipher, right? What's going on here? This is equilibrium, so where should I focus on in terms of the equilibrium? Point B, that's the particle that I will consider, right? So that is the first thought process that is crucial for you to be able to do, right? If you are confused what to do, is point C, point B, whatever, hopefully you have done enough exercises by the time you face your exam, so that these things become just, okay, understand. That's the first thing. Second, if the understanding of pulley, right? That is where it got crucial, right? Okay. If we know it's about equilibrium of a particle and the particle is point B, so straight away the first step to draw the free body diagram you can do, right? Point B. So you have three forces. One force is here, and then you have force here, and then you have force here. Again, to the concept of free body diagram, if you still draw something else, be it pulley C or whatever, then it is still not a free body diagram. Alright, of a particle. This is a particle. Right, so this one is F2, and F2 is unknown, we do not know. Next, the crucial part in terms of understanding pulley and cable, right? So if you can see from F1, it goes to point C, and then it goes to point B, and then it goes point A, right? So all of those are the same cable, meaning when the same cable, the tension is the same, right? Meaning what? Meaning that this force and this force is the same, right? So okay. Okay, so sorry. So meaning that this one is 1000 Newton, this one is 1000 Newton. So that is the second point that is crucial in order to be able to solve this question. Right, if you do not know this, you will be stuck, because this one from understanding of cable, right? So point C is a not cable, a pulley as well, right? Point C is a pulley, point B is as well a pulley, right? It's different from the previous question where it is a ring. I think in the lecture you have understand this already, right? If it's a ring, if you have multiple cable, it's all different cable. But if you have a pulley, the same cable actually goes through the pulley, so it's the same tension, right? So there. Now to the dimension. For this part down here, because x is given, if you see x is 1.5 given in the question, so this triangle should be known, right? So x is 1.5, that's 2. So basically this is 3:4:5 ratio, right? Okay, because it's 1.5 and 2. If you multiply by 2, it's 3 and 4, right? The ratio is 3:4:5 then. Or if you want to use 1.52 as can as well, 1.5, 2 and 2.5, right? It's the same ratio. This one you don't know, right? So when you don't know, you have to assume. So we'll put an unknown here, theta, because we do not know. We do not know y, right? The distance y we do not know, so angle is still unknown. Easier to use theta than you use a triangle of 1.5y. That will cause more headache, right? How to square root or whatever, right? So just use theta. Okay, yeah. Main kakak. Okay, so alright, so here is quite straightforward. Once you have established the free body diagram, it's just how to solve equation of equilibrium, right? So we solve the easiest one first. So summation of Fy equal to 0. You have always option of Fx and Fy, right? But you can see which one you should start first. If you use x, you have unknown here and unknown here. Two unknown, you cannot solve. If you use y, you have only this unknown, because this one is not having any y component, right? So might as well I start with Fy. Summation of Fy equal to 0. So we have 1000, this upward here, sine theta. This one, right? And then minus 1000. What is this? 4/5 equal to 0, right? So then straightforward. Then because if you bring that and you can cut off, so sine theta equal to 4/5. Theta you can calculate to be 53.13 degrees, right? So depend on which one you want to solve first. If I want to solve F2 first, then I can straight with summation of Fx to 0, right? So you have F2 minus, because theta is already known, so minus 1000 cos 53.13 degrees, and then minus 1000 3/5 equal to 0. So F2 you can solve to be 1200 Newton. Verify the answer as usual, right? Do calculate and verify whether there's any mistake or not, right? So you will get that value. Next you need to find y, right, according to the diagram. So this is just a triangle. So you have the triangle, this is y, this is 1.5, x is given as 1.5, right, earlier. So, and we know already this one is 53.13 degrees. So it is simply just, you can use tangent, right? So tangent 53.13 degrees equal to y over, okay, y over 1.5. So from here, y can be solved to be equal to 2 meter, right? And there you go. It's quite a short question, this one. It's just that some students take a long time if they lack in practice. So when they see the diagram, they do not know where to start. So that is the importance of having enough practice. All right. Hopefully it's understood. We can move on to question number 3. Okay, this is question number 3. You have the diagram on the left. We have question part A. Determine the maximum weight of the bucket that the wire can support so that no single wire develops a tension exceeding 0.5 kN. What will happen if the weight of the bucket exceeds that maximum weight? Right. So, do you understand the question? Hopefully you can, because I will put the diagram there, but the written of the question, hopefully you can go back or you can refer to the PDF, right? So again, we have the structure there, and from there I think you should be able to tell also that this is equilibrium of a particle, and we have two particles there, point B and point E, right? So you have two free body diagram and twice the length of the calculation, roughly speaking, as well as the way the question is framed, right? For example, it says we need to find the weight of the bucket. So the bucket is the question right now. So what is the weight of the bucket? So the weight of bucket. So that is the final answer that we need. The condition is the wire can, no single wire develop a tension exceeding 0.5 kN. So we have many wires there, right? Many from A to B, B to C, B to E, E to D, right? All of those are wire or cable, right? So the condition is none of them exceed 0.5. So that is the maximum, 0.5. So my question is, which one is 0.5? Or all of those are 0.5? Right? Think for that for 1 minute before, or pause this and think before continue on, because I will straight away discuss. But I just want to know whether you can understand what that means when it says no single wire, meaning the condition is what is the maximum weight. Of course, when you increase the weight of the bucket, all the tension in the cable increase, right? You for the heavier bucket, much more tension, much more force in the each cable. I think you can understand. But the condition is no single wire is exceeding 0.5 kN. So what does that mean? Okay, think, pause, and then continue. I expect you already think and thought about it. So any of you actually think that, oh, that means that every single wire is 0.5. If you think like that, that's wrong. Do you understand why? Because if you understand like this, I do not know how to draw, but just using that as a reference there, right? If I put more weight on the bucket, of course tension of ED, EB will be more, right? And then when EB will become more, of course AB and BC is become more as well, right? Because all of that are connected. However, each force in that is different, right? Meaning the force in each cable will be different. So there will be a time when you increase a force at that point, one of the cable will reach 0.5. Only one will reach 0.5 first. When that happens, you cannot add any more weight to the bucket, right? Because if you add, it will exceed. One of the cable will exceed already 0.5. The other may not reach 0.5 yet, but one cable already reached 0.5. So the question is, which one? Which one will reach 0.5 first? So that's the question. So this is where it requires you to understand, okay, that is the scenario. Now I have to understand which one will reach the 0.5 first. Okay, so there are many ways to do this. One is by assuming and checking. That can be quite a long time if you do. Okay, I assume, for example, I assume BC is 0.5. Then I calculate something else becomes 0.6 something, etc. Right? So that already exceeds 0.5. So my assumption is wrong. I have to repeat back again. Or I assume something else. That can be taking too much time. So one of the way, of course, none of the way is wrong. It's just that in the exam you have limited time. So one strategy that you can see is to see, okay, which force will be the maximum. Okay, to be able to do that, we have to know how they relate to each other. So from there, you have to start from the basic, which is free body diagram, right? Okay, free body diagram. You have two free body diagram basically, as we mentioned, point B and point E. So at point B, you have one force here, one force here, and one force downwards, right? Where this is 30 degrees, downwards is 3, 4, 5. 3, 4, 5. So we label this, for example, FAB, FBC, FBE. Let's label it like that. Right, and down here, but to save space, I will draw it here. This is point E, right? So you have this force corresponding to this one. So this is FBE at the angle 3, 4, 5, right? This is the same force. This is the same cable from B to E. And then you have this force here. And then you have force down. This is the weight that we not want, which is the weight of the bucket. Right, and then this is FDE, for example, with the angle of 30 degrees. Right, that is the two free body diagram that you have to be able to draw, and I assume you know how to draw this already. Next is express the equation of equilibrium and then see how the forces relate to each other. Then we can see, you know, which one is bigger. The idea is I want to know first which of the cable reach 0.5 first, meaning that I want to know which is the biggest force among all of these forces, right? Because that biggest one will reach 0.5 first before the rest. The rest will be still smaller, right? And when we keep increasing, one of that maximum is already going more than 0.5. Okay, so let's see what I can do here. For example, from free body diagram here, if I do summation of F y equal to 0, because I want to just compare two forces, right? This and this. So I have FBC sine 30 degrees minus FBE 4/5 equal to 0, right? So which one is larger? Of course, you can rearrange to make it easier, right? So for example, you get FBC sine 30 degrees, and then you bring it there, etc. So you get 5/4 equal to FBE, right? Okay, this one is actually two step in one, right? So first you bring it here, become 4/5 FBE, and then you bring that 4/5 here, become 5/4. So do not need to jump steps. You can do step by step to be safe. I'm just not enough space to do every step, so some steps that can be understood, I just jump step like that. Okay, from here, okay, all right. So if you rearrange this one, you'll get 5/8, right? 5/8 FBC equal to FBE. So from this relationship, can you determine which one is larger, which one is smaller? Right? Logically, you should be able to, but if you cannot, you just substitute number, right? Logically, you can see that FBC is larger than FBE. For those who cannot see, why? So just assume, let's say, if you put, let FBC equal to 1. If FBC equal to 1, FBE will be what? Will be 5/8, right? You plug in 1 here, this one become 5/8 or 0.4. So which one is larger? This one is larger, right? Compared to this one. So FBC is larger than FBE. So that's how you just substitute and just check, oh okay, that one is larger. Meaning that between these two, this is confirmed not the highest force because it's smaller than this one. Is this the largest one? We have to compare with something else first, right? Okay, so let's compare with FAB. So if you do summation of Fx equal to 0, you'll have FBC cos 30 degrees, and then you have also plus FBE 3/5, and then minus FAB equal to 0, right? Now what I want to compare is FBC, right? FBC and FAB, right? Because FBE is already smaller, so this is no longer a candidate. This is not a candidate for the maximum force. This is a candidate. This might be FAB as well. We do not know, so let's compare. Okay, so after you have obtained this equation of equilibrium for Fx, what our intention is, we want to compare the candidate for the maximum force, right? The largest force among all of these, right? So we know from here this is no longer a candidate. FB is no longer a candidate, it's smaller than this one. So I want to compare FBC with FAB, right? This is no longer a candidate. I want to compare between these two. So what is ideal if I can change this FBE into FBC? So I can use this one, right? I plug in this FBE, the whole thing here, right? So FBC cos 30 degrees, and then plus, if this whole thing goes in here, 5/8 FBC, and then you have 3/5, then this bring over there equal to FAB. So if you solve this one, let's see, you'll get 1.4434 FDE. Sorry, which one am I calculating? I'm confused already. So FBC is sorry FBC cos 30 plus 5/8 FBC 3/5. That will 1.241 FBC equal to FEB. So which one is larger, which one is smaller? You can use the same exercise, just plug in 1 into here, and then you'll get this one become 1.24. So I don't have enough space already. So FBC is smaller than FEB, right? Because if FBC is 1, FAB is 1.24. So this one is bigger, right? FAB is bigger. So just between these three comparison, we haven't gone this way yet. Just from here, we know already that if we arrange, FAB is bigger than FBC, right? FBC also bigger than FBE, right? So far, that is what we have concluded from these two. Hopefully you can follow so far. We haven't yet calculated anything. We just first trying to see which one is reaching that 0.5 maximum force first, right? So currently this is the big candidate because this is smaller, this is smaller. We have to compare this with this one, FDE, right? Okay, hopefully you are still following. Now from here, if the summation of Fx equal to 0, you'll get FDE cos 30 degrees minus FBE 3/5 equal to 0. Okay, right now we have established this relationship, and now we are trying to relate what about this one, right? So far this 2 is no longer a candidate for the maximum force, FAB is, but we do not know for FDE, right? FBE is already the smaller one. But let's just compare this relationship first. So if we compare this, we will get what? FDE cos 30 degrees, and then 5/3 equal to FBE, right? If we calculate this, FDE and FBE, FDE and FBE, 5/3 cos 30, okay, 1.4434, 1.4434 FDE equal to FBE. So from here, which one is bigger? If FDE is 1, FBE is 1.44, so FDE is smaller than FBE, right? So given that relationship, actually that makes our comparison much easier, because then FBE is bigger than FDE, right? So from here, obviously this one will be the maximum one, right? So FAB, FAB will reach 0.5 kilonewton first. So having understand this, we know that FAB will reach 0.5 kilonewton first, right? The first question that we have in the beginning is that the condition is none of the wires should exceed 0.5, but the question is which one will reach 0.5 first, right? So from this comparison, we know that this is the biggest, so this will reach the 0.5 first. So in the condition where the maximum weight of the bucket is FAB equal to 0.5 kilonewton, right? This is FAB, right? FAB here, that is 0.5 kilonewton, and then we can start to calculate until we can calculate W, right? So we can just plug in everything, right? So now we have FAB, so FAB we know, so now we can know FBC, right? So from here, FBC, you just plug in 0.5 to FAB, FBC will become, so 0.4029, 0.4029, 0.4029 kilonewton. So you know FBC. So and then we can plug in here, right? FBC we know already. We multiply, we can get FBE. So FBE, if you plug in, you will get 0.2518 kilonewton. Again, all of this number, please do verify. We have already FBE. We can plug in here, right? FBE we know. We can calculate of FDE. So FDE will be, when we calculate, you get 0.1745 kilonewton, right? So as you can see, obviously none of this force is reaching 0.5 first, because 0.5 is reached by FAB first, the rest is smaller, right? So having all of this, we can calculate what is W, right? So we need to know another equation. We need to do another equation that we haven't done yet, which is summation of Fy equal to 0. So right now we know all the value already, so we can straight away plug in, right? So FBE is this one, so 0.2518, 4/5, and then plus FDE is this one, 0.1745 sine 30 degrees minus W equal to 0, right? So then W we can calculate to be 0.289 kilonewton. That is the final answer. Alright, so hopefully you understand this part. Hopefully you can still hear my voice, because there's so much noise here. Alright, so that is how you calculate the weight, the weight of the bracket in the condition that none of the cable reach 0.5. Right, so this is one of the type of question that I think you need more practice on, because it does require certain practice to be able to understand the concept. Right, and do not assume something, or do not make everything go to 0.5, etc. Right, and because some students actually understand, oh, no cable should be more than 0.5, so maximum everything is 0.5, but that is not logical, because if you put any of the equation, you put this is 0.5, 0.5, it will not equal to 0. So if you do something like that, the examiner say you are not fit to be an engineer or something, right? So that's the worst case scenario. So that's the third question. We'll move on to the fourth question. Okay, we are here for the fourth question of today. You can see the diagram on the left, and the question goes, if the maximum tension that each of the cable AB, cable BC and cable CD can sustain is 685.6 Newton, determine the maximum weight of the cylinder E and the cylinder F. Angle theta is 15 degrees. So if you see to the diagram, the angle theta is already given, right? But we want to calculate is what is the maximum weight E and F. Alright, so if you look at the question, again the diagram is there. This is actually similar to the question number 3 just now, where the condition is given, but we do not know which one will reach the maximum first, right? If you understand, the maximum tension that each cable can sustain is 685.6 Newton. That is the capacity of the cable. But in the current circumstances, we do not know which cable reach that value first. Hence, we have to compare, just like the previous question, right? So hopefully you understand, because some students I know they find it hard to understand. The question says maximum each cable can go is that. Why is that this the value? No, when you say the maximum that this can undergo is certain value, currently it may not reach that value. Currently maybe it's 0 force, right? And then I try to pull or push or whatever, it becomes 1, 2, 3 until it reaches the maximum, right? So maximum value only state that that is the maximum that it can reach. It doesn't mean that in a given circumstances, in the current situation, it is at that value. It may be lower, but it cannot be higher. That's the meaning. Alright, so again, the steps will be as before. We have to draw the free body diagram, get the equation of equilibrium, compare the forces, see which one is bigger, and then we know, okay, that is the maximum. So if you do the first step, free body diagram, so we have point C, so we have force here at 30 degrees, we have force downwards, and then we have force here. And then the question actually already give theta is 15 degrees, so this one is 15 degrees. So we have weight of E, we have weight force BC, and then we have force CD. And then we have here at point B, this is point C, right? And then this is point B. So we have force here, this is 15 degrees, this is FBC. And then we have weight of F, and then FAB at 45 degrees. Okay, that is the free body diagram. Right now we want to relate the force. Of course, fortunately, this one should be a bit shorter than the previous question, because we do not have as much force or cable. We only have 1, 2, 3, right? So here, if we do summation of Fx equal to 0, relating these two, so okay, first expressing equation of equilibrium, so we have FBC cos 15 degrees minus FCD cos 30 degrees to 0. So if we rearrange this, FBC cos 15 degrees divided by cos 30 degrees equal to FCD, right? So here if you see the value, it will become 1.1154, right? So 1.1154 FBC equal to FCD. So which one is larger? So FBC is is smaller than FCD. Again, just substitute, right? If FBC is 1, multiply by FCD become 1.11. So of course this one is larger. What about this one? So here if you do summation of Fx equal to 0, we will have FEB cos 45 degrees minus FBC cos 15 degrees to 0. Right, so if I am to do FEB cos 45 degrees over cos 15 degrees equal to FBC, I will get 0.7321 okay, 0.7321 FEB equal to FBC. Meaning what? Meaning FEB is larger than FBC. Why? Because if FEB is 1, FBC becomes 0.73. So this is smaller. So from here, you can conclude that which one is largest? FEB is larger than FBC, right? And FBC is larger than FCD. So this one is largest, right? So FEB reach 685.6 Newton first, right? So given that, so if I continue here, so FEB is 685.6 Newton. 685.6 Newton. So from here, if you know already FEB, okay, where is it? If you know FEB, you can calculate for FBC here, right? So you plug in here, you get FBC. So FBC equal to 501.9 Newton. And then if you know FBC, you can calculate for FCD, right? So FCD equal to 559.86 Newton, right? Do verify all these numbers, right? Do please verify all of these numbers. Okay, so having all of this, then we can solve for WE and WF, right? So we haven't done the summation of FY yet. So for this one, okay, so we have in the exam you have to relate properly, right? This based on FBD of C, summation of FY equal to 0, you will get FCD, which is this one, right? 559.86 sine 30, and then minus FBC, which is this one, 501.9 sine 15, and then minus WE equal to 0. Oops. So from this calculation, you can calculate WE equal to 150 Newton. That is the answer. And then for this particular free body diagram, we can do summation of Fy equal to 0. So we'll have FBC, which is this one, 501.9 sine 15 plus FAB, which is this one, 685.6 sine 45 degrees minus WF equal to 0. Can you see until that point? So WF, if you calculate, it will be 614.7. Is it Newton? Newton. Right. Of course, for all of this calculation, please verify the number in case any mistake happen in my calculation. But the steps, the chronology, and the method of calculation is as such, right? Yeah. What else? Okay, so that's actually question number 3 and 4 is quite challenging if you do not understand where to begin. If you understand where to begin, next steps is quite straightforward because it's just the normal step from equation of equilibrium to solving, right? But the condition is where it gets tricky if you do not understand. So please make sure you understand based on question number 3 and 4 what it means when the question say the maximum that this and this and this can go to is this. It doesn't mean that everything is at that, but it means that that is the maximum. So when the bucket or the weight is maximum, so one of the cable will reach the maximum first. So which one? And yeah, from there on you calculate. All right, inshallah. So now this is a bit of what to say? A bit of a side note, right? Side note that if you see the PDF of the question or in when we cover the question anyway, right? There's a mark there, right? 15 marks, for example. That gives you an indication of how much time you should spend in maximum for each of these questions, right? Because in the exam, okay, if I give you some idea, right? In the exam, in the midterm, especially this subject, these topics will tend to be in the midterm. In the midterm, you have 2 hours or 120 minutes, right? That will give you 100 marks. Meaning the question, if you add all the marks, is 100 marks in the exam, right? In the exam. So it means that if you divide, you get 1.2 minute per marks, roughly, right? If you understand the ratio. Meaning for each marks, 1.2 minute is allocated there. So when question like this, which give you 15 marks, then you can calculate how many minutes that should be allocated there. So it would be roughly what, 17 minutes based on the ratio, roughly, right? If I'm not mistaken, 16.5 minutes or 17, 18 minutes, etc. So if you solve question like this or question 3 or which question that give you, if you see the question it's 15 marks question, if you spend more than 20 minutes, meaning you really need to practice more, because that is the time that is given to you to solve the whole thing, right? If you spend more, it means you take time from other question, and in the end of the exam you will find that you do not have enough time to solve all question, which is such a thing that you want to avoid. You want to have enough time to cover all, right? And hopefully at the same time you avoid mistakes. But if you don't even have time to cover all questions, then that's the worst case scenario that we want to avoid. So make sure you just pace yourself, see how many minutes you solve for each question of this, like this. Try to meaning after you have gone through this, close everything, close notes, etc. Just see the question back again, try on your own. and then see how many minutes you take, right? So yep. So with that, I think that's the end of this tutorial for 2D, two-dimensional equilibrium of a particle problem. Next tutorial will go on 3D problem, right? So really make sure everything, normally in each chapter in our subject statics, we will start with 2D, we'll go to 3D. Normally the 2D is the simpler question and the 3D will be more complex. So if you have any problem with the 2D, please make sure you ask, you discuss to understand, so that it's not too late when it's going to 3D, right? Yep. I think that's the end for today. Thank you. Hopefully there's not too much noise, etc. throughout, because this is a phase of working from home. This is at my home, and of course at home we cannot stop from all the noise to come in. We have kids, so hopefully you can still focus, and what I explained still, you know, effectively reach your end, and hopefully this have help in understanding what you need to understand. All right, so as a closing, if this have been beneficial despite the sound of noise, etc., do like the video. Hopefully it helped in terms of the YouTube algorithm. And with that, inshallah, we end the session. Subhanakallahumma bihamdik, ashhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wassalamu alaikum warahmatullahi wabarakatuh. See you in the next tutorial.